Let's see. I think recording will start now. Okay, it's not yet started, but okay. Can you just give me a overview what was covered in the previous class? Because Arnav is not here today. I'm just standing in for him. I'll be taking today and maybe one more lecture on Wednesday. What was covered in the previous class? Somebody wants to summarize?
Sir, could you please clarify that is this meet for BTech 2020 for DSE students also?
Yeah, one sec, hold on. Megha Sharma, outside education. So I'm not sure exactly what it is. So this is a course which Arnav Bowser is taking. It's either called CS669 or DS403. Or maybe it's a mix of both. So I'm not sure exactly what it is called. So there are data science and there are, like it is for BTech data science and for MTech, MTechs also are there in the course, something like that. Right? So you're, are you in the right place? Okay, so I think maybe, so I'm not sure how so I had sent out an email earlier in the morning, and I think because I'm not officially part of your group, it probably did not get delivered. So I think since I waited here from 1 o'clock and since nobody turned up, I sent a mail to the student's ID and that I think got through. So anyway, fine. So I guess all of you are in the right place, right?
Yes.
Okay. Okay, yeah, so the meeting is being recorded. I will share it somewhere and you can, I'll share it on YouTube or something and share, give the link, share the link with you guys. Okay, so we'll start. So can you tell me what was covered in the previous lectures by Arnav? Did you cover about classification? Some basics were covered or? You have to talk to me, otherwise.
So you taught us about general what is learning. We had some discussion about what is learning, what assumptions learning is based on. Then he taught us about types of learning, just overview of type of learning like associative learning, generative learning, descriptive learning, insightful learning. And then he classified it basis on the basis of whether they are supervised learning or not, and also regressive learning and discriminative learning.
Okay.
And
So
then
these were explained to you at more or less a high level.
yes, sir. Just overview of the.
Okay. So none of the mathematics was covered.
Second lecture, something about distribution was discussed.
Okay. Yeah. So I think the assumption is that you already know probability. So I am also going to follow that assumption today. But let's see. I've got some material I've taken from Bishop's book, which covers some basic probability. So you can have a look at that. I'll go through that today. Anyway, Srijan Singh, thank you for that input. Okay, so some of this material whatever I'm covering today might already have been covered by Arnav. So kindly bear with me if that is the case. But anyway, let's see how things go. Maybe I'll give it a different perspective. Okay, so suppose so I'm not going to explain what is classification or what is pattern recognition, the field itself. Some history might have already been told to you. Is my voice okay, or is the audio breaking up?
Yes, sir. Okay,
fine. Yeah. So okay. So for example, let's start with an example. Okay, so we are interested in making machines which can recognize patterns, right? So we as humans and as other animals have developed this cognitive ability through evolution. Like millions of years of evolution has given us the ability to interact with other people and to sense our surroundings and all that, and that is how we survive, right? Now we are able to see, we are able to sense, we are able to smell and touch, and so many things we are doing. So in general, pattern recognition is, you can say, one subset of AI where you try to get machines also to do similar tasks. So let's think of an example. Okay, so suppose that you are given an audio sample. I consider myself as an audio person, so my examples are maybe biased a little towards audio. But suppose you are given some audio sample and you want to make a machine recognize whether it is a male who is speaking or whether it is a female who is speaking. Okay, you want to detect the gender from the voice. So as humans, we are able to do it, right? When we hear somebody's voice on the telephone, or when we hear something on the TV, although we are not, suppose we still don't see the image in the TV, but we are sitting in the back of the TV, say, we are more or less able to detect from the voice whether it is a woman who is speaking or whether it is a man who is speaking. Do you agree?
Yes, sir.
Yes,
Yeah.
sir.
Yeah.
Yes,
So I'm assuming that all of us know what I'm talking about, right? So let's say let me actually share my screen. Which screen? Screen 2. Okay, so can you see my screen? Okay, it should be coming now. Can you see my screen?
Yes,
Yes,
sir.
sir.
Yes.
Yeah. Okay. So what I've done is I have loaded a couple of audio files in. So this is some tool which I can use to visualize and measure some properties in audio file. I'll try to play it out. Hopefully you'll be able to hear. I'm not sure how good. I mean, because this Google Meet, I don't know how well because it transmits from the far end. But let's see whether you're able to hear the voice. I'll bring my mic close to my speaker.
Had your dark suit and greasy wash water all year.
Can you hear that? I'll play it once again.
She had your dark suit and greasy wash water all year.
Did you hear?
Yes, sir.
Was it a male or a female speaking?
Male.
Maybe.
Okay, I'll play the other one.
She had your dark suit and greasy wash water all year.
Sorry, it's a little low volume, but I'll play it.
She had your dark suit and greasy wash water all year.
Yeah, was there a male or a female? The second one.
Female.
Yeah. So the first one was the male speaker, and the second one was a female speaker. So your cognitive ability, your hearing ability has allowed you to determine correctly whether it is a male or a female speaking. Correct. So now our job is to try to make a machine to do this. Fine. So were you able to detect the speech? What was spoken? Were you able to hear what was spoken?
So it was not clear from the sound.
Okay, I'll play it once again, although it is not relevant to our example. But
Means we can hear the voices. Means we can find the voice of male and female, but we cannot hear through the laptop or the machine that it is what he's saying. Actually, it's not clear.
yeah. So let me play it.
She had your dark suit and greasy wash water all year.
Did you hear what was being said?
So something.
Anyway, yeah, it's okay. But at least were you able to recognize that it was an American accent?
Yeah.
Yes, sir.
Yeah, so it was an American accent, and actually the sentence is, she had your dark suit and greasy wash water all year. So if you work in speech, if you listen or if you do some research in speech, this is a very famous sentence in speech processing, and this comes from a particular speech database. It's called Timit. Okay, it's a very old one. It was developed, I think, in the 1970s. Anyway, so our objective is now to detect if it is a male or a female. We let's say we have some device we want to design which is able to, given the voice, it is able to tell us whether it is a male or a female which is speaking, right? So now with my I'm going to give you some information. Okay, so in speech there is something known as fundamental frequency, okay, or the pitch of the speech. So in the top part of the plot here, I have plotted, this tool has plotted the pitch contour. So pitch varies with time. And so this is the wave surfer 2 here. This is the male speech, and this is the pitch which is estimated from the speech. Okay, so I'll not get into what is pitch, but pitch is essentially the fundamental frequency by which how much some portions of the waveform repeat by itself. Okay, so it can be so there are a lot of techniques to estimate pitch. So this is the pitch, and so pitch is in some sense the measure of frequency. So the unit is in hertz. Hertz is the number of cycles per second. Okay, so so you can see that this is the male speech and this is the pitch, and so you can see, so you might be able to see some values here at the bottom in this part of the plot. So I'm not sure if you are able to see, but you can see it here that okay, here it is 176 hertz, 196 hertz, 199 hertz, 161 hertz, 182 hertz, 222 hertz, there is 146 hertz, 186 hertz, and so on. And here there is 143 hertz, 149 hertz. So so this is the typical pitch value of this particular speaker for this particular sentence. Fine. So it's around 140. So it varies from like 180 to, I mean, so 140 to maybe around, even we also got 200 and something, 220 or something. Okay. So this is the pitch of this male speaker. Now let's compute the pitch for the female speaker, and you can see here. So this is about 193. This is 239, 245 hertz. Here is 216 hertz, 210 hertz. 204 hertz, 211, 182, 185, 199, and so on, 194. Okay, so on. So this is the range for female. So the pitch for the female voice also varies around maybe something around 190 to maybe 230 or 240 hertz. Fine. So pitch is a single value, like a scalar value, just a number. A pitch is a number. Fine, and don't worry about what the pitch is, and the pitch varies with time. So you have to measure the pitch at various locations of the waveform, and you get some values. Okay. Now suppose some speech expert comes and tells you that the pitch can be used to distinguish male and female, because we generally have heard that males have a lower pitch, males have a low pitch voice, whereas females have a high pitch voice. We've generally heard that, right? Females are able to sing maybe at higher frequencies or at a higher scale than males. Male voice has more lower frequencies, like bass frequencies, whereas female voice has higher frequencies. So the pitch of female voice is higher than that of male. The pitch of children are even more. I mean, small kids can like scream like very high frequency. Okay. So generally, so now some speech expert has come and told you that you can use the pitch to distinguish between male and female. So that is what you're going to do in your device. So you measure, your device has some microphone, let's say. You measure the audio, measure the speech. I mean, you record the speech, you sense the speech, and then you come up with some estimation of the pitch. So here we are making some assumptions that the input to the device is only speech. I mean, the data is always valid, and it is always the device will work only when the correct type of signal goes to it. Like for example, if some if nobody is talking, then the device will not do anything. Okay, and also if some birds are singing, or if somebody is singing or something like that, then also the device will not show you an output, because the device is meant only to determine from speech whether it is male or female. And there are only two classes. I mean, here we are only having two classes here, either it is male or it is female. So these are the assumptions which we have, and we are going to assume that the device is provided appropriate input. Okay, so the device does not have to say, okay, this is not speech, so I will not work. No, so we are making sure that we will give only valid inputs to the device. Fine, is this much clear?
Yes, sir.
Yes, sir.
Okay, so now let me open. Oh, sorry, where is my book? Okay, I don't have any handheld notes. I mean, I don't have any. I've written some handheld notes which I'll share with you. Can you see the screen?
Yes, sir.
Yes, sir.
Yeah. So
Yes.
this is what I just said. Okay, we are going to use fundamental frequency of pitch too. So this expert who has told you that the pitch can be used to distinguish male and female, that is an example of a feature. We are extracting some useful information from the raw signal here, which is the audio signal, which is the speech signal, and we are extracting the pitch, which we are going to use as a feature for this task. So now if you plot, so in this axis here, I have drawn, because pitch is a scalar value, I've drawn pitches for males and females. Okay, so you can see that around 180. So this is 180, this is 210. So you can see that in general, mostly the females have a higher pitch, and there are some, and generally the males have lower pitch. Okay, so on this axis. But in general, but it overlaps. I mean, like some males might have a higher pitch, which overlaps the pitch of the females, and also some females might have lower pitch, which might mix with the pitch of the male. Okay, so as a feature, pitch is probably not perfect for us, but we are going to assume that it does a reasonable job and it is sufficient for our purposes. This is the pitch value in hertz. So the classification which we want to do is we want to identify G. G is the random variable here, which it takes two values, F and M. It's a discrete random variable which takes either F or M. F is for female, M is for male. And basically we need to estimate the probability of G. Okay, that is, we want to estimate the probability of the gender. So there are two things here. Okay, see, suppose you don't have the pitch measurement with you. Suppose you don't have the pitch measurement with you. You for some reason you're not able to measure the pitch, and still you must predict whether it is male or female. Then what will you do? Did you understand my question? For some reason you're unable to measure the pitch. Now how will you determine if it is a male or a female?
So what input do we have? I mean, only we can listen to them.
No, nothing. There's nothing given to you. No, there is no input. Still, you have to predict. What will you do?
So, do we have any data?
Random guess.
Random guess. Some other answer, please. I'll come back to your random guess in a minute. Somebody else said something?
So, do we have any data?
No, we don't have any data. We don't have any data. Nothing. You only have to say whether it is male or female, given nothing.
Means we have the sound now. Means we have
no, there is no sound. Nothing is given to you.
Okay.
There is no audio.
0.5 probability that it's a
Sorry?
male. 0.5 probability, half probability.
0.5. Okay, that is some answer. Any other answer?
Do we have
Sorry?
pitch value?
Huh? Sorry?
We can apply conditional probability.
You have, maybe if your video is bad, or if your network is bad, please type. I'm not able to hear many people.
So perhaps we can do something, assuming that we know that the population of the men and women in the world is half. So the speech sample that we have, whether that's a man or a woman, that's also half. So that's the
So
only logical
finding
conclusion we can make.
so finding the mean and then finding to which mean is it closer?
Mean of what? There's no input given to you, right? There is no input given to you. What we will measure the mean of what? Yeah.
So do we have
Huh?
do we have pitch value? Pitch
You
value.
do not have
value.
pitch
So do we
value.
have
You
pitch
do
value?
not have the pitch value.
So if you don't have anything, then you can just set 0 because you didn't hear anything.
No, you need to get you need to show some output. You need to show either F or M. That is required. You are bound to show some output.
So we have the probabilities are not 0.5 for both of them, F and M, in the data set.
There is no data set. Where is the data? I'm just, don't get biased by anything. You think openly, and there's no data set. Where is the data set? I did not say anything about data set. You just have a device which has to say whether it is male or female. It has to show out male or female.
Then we can default either of the values.
0.5 chances of either.
Okay, fine. Yeah, you have given various types of answers, and I think some of them are quite close to the answer. See, if nothing is given to you, okay, you should probably make a guess. See, you think of it like this. Suppose you are having this device, and every time you make a correct guess, somebody gives you some money. Okay, every time you make a correct guess, somebody gives you money. So your objective is now to make maximum money. So that means you should try to guess in such a way that your guess is correct most of the time. Okay, so now nothing is given to you. There is no speech given to you. Still, you have to decide whether it is male or female. So one thing which you should ask, or your common sense, what you should do is, you should ask, where is the device located? Where is the device located? So if the device is located, let's say, in a girls' high school, or in a girls' school, or in a girls' college, if the device is in a girls' college, then what should you, how will you predict F or M? Should you predict F more times, or should you predict M more times?
F more time.
If it is in a girls' college, we are going to assume that most of the students are girls. Most of the teachers are also girls, but there may be some men also as faculty, or some men also may be working in the college. Okay, but still, it is, you will get more money if most of the time if you say F. It is probably not a good idea to say F all the time. Is it better to say, is it good to say F all the time?
No, sir.
Yes, sir.
No, sir.
How will you decide that?
So it depends
Sir,
on the
if we are in
condition.
a girls' college, then probability of being a girl's voice is more than boys.
I know. My question is, should I say only F? Should I only output F, or should I occasionally output M also? That was the question.
No, sir.
Sir,
It
only
depends on the conditional probability.
F only.
Because with
Don't
given
talk about conditional
female.
probability and all right now. So we are not. Don't worry about probability right now. We are not going there now.
There
So we
might be
should output
male
only
teachers.
Sorry.
Sir, there might be male teachers and the staff.
Yeah, so like I said, no, in some girls' colleges there may be some men also working there as.
Yeah, I also want to add in something. There might be men working there, but if I'm getting a reward for every time it is a female, and the probability of it being...
No, you get a reward every time if you guess correctly. If the output is correct, if the prediction is correct, then you get the money. Otherwise, you don't get money.
Okay, so then, but since I don't have any set basis for deciding whether it's a male or a female, so if I go with like the maximum number of times of choosing it to be a female, it is more likely to maximize my reward.
I agree. In a girls' college, most of the time the device is going to pick up or be surrounded by girls, so it makes your life easier, or you're likely to make more. You're likely to make less mistakes if you predict more times that it is female than it is male. Okay, so how will you? So do you want to say 80% of the time you should say female and 20% you should say male, or do you want to say 95% it is going to be female, 5% it is male? How will you decide how much you will say? How
Sir,
many times? Huh?
Sir, we keep on saying female until and unless we get a wrong result. And since when we are getting wrong result, then after that many attempt, we'll start changing our value at that attempt.
No, that is very complicated. Let's not get into those kind of stuff. Like we just want something very simple. We want a
We can sample it, sir. We can sample the examples a few times.
Sample the examples. Okay. See, probably the best thing you should do is, like I said, you should determine where it is located, which college, and let's say in that college, suppose you find out whether, I mean, you find out the number of girls in the college and the number of men in the college. If it is a college which has only females for some reason, if the college has only females and the device will be, there is absolutely no chance of any male voice around that device, then you must always give the output as F.
So,
okay, but if there is if there are, let's say, out of 100 staff members or 100 people in the college, let's say 10 of them are men, then probably saying female every time is not a good idea. It is maybe better you should say 90% of the time it is female, 10% of the time it is male. I mean, if you have no other information, this is probably it can be shown that theoretically it can be shown that if you have such a case, 90% female and 10% male, it can be shown that the least error will occur when you say 90% of the time it is female and 10% of the time it is male. Okay, yeah, somebody had a question?
Yes, sir. I think that the whole, the credence on which this logic is based is itself incorrect, because earlier we had no information about anything, and now
we
we're
still don't have
assuming.
it. No, we still don't have information. We don't have information. We have no information.
We have no information, and suddenly we have information of the location of the device. And if I want to extrapolate that further,
Can I interrupt? So
yes, sir.
I said when I said I have no information, I meant that there is no speech information. That feature is not there with us. There is no audio information. I'm not saying that there is no information at all. That's not what I meant. I meant that there is no feature. We are going to use pitch as the feature, and we are going to currently assume that if the pitch information is not available to us, how can we make our guesses right most of the time? Is that clear?
That's what I was asking. That,
one person at a time. So you please wait. Let Aniruddha finish. Is my point clear?
Yes, sir. But if we don't have the speech information available, then
we don't have the speech
how is the
information.
device working?
How assume, for example, the mic of the device is damaged. Assume, for example, the mic of the device is damaged.
So we're basically just hard coding the output based on where it is located.
Yes, right now that is what we are doing. Exactly, right now that is what we are doing based on what information we have about the college and what tells about the college. We are hard coding the answer. Fine.
Okay.
Yeah. Jainan.
So I was saying that means we are basically hard coding it based on the sample space itself, right? Means what is the what space are we taking the inputs? That is basically
your voice is breaking. I'm not able to hear what is it that you're saying.
Yeah, so I was saying that
you can either can you type it out? Can you
sure.
chat? Okay, so that was the situation which I said when you have no information. Okay, no information in the sense no pitch information, no speech information. Our feature is not there. So given the situation, the best thing to do is to predict it based on what prior knowledge we have, and that is what I'm calling as prior knowledge. This PFG. PFG is the probability of guessing the gender given nothing. We don't have any feature information. Only the prior information is there. So who will give you the prior information? Somebody has to give you the prior information. You have to get it from somewhere. Somebody has to tell you that where it is located, or you have to find it out. Some information is needed. Otherwise, like somebody said, we can just do a random guess. Okay, if prior is also not there, then you have to do some randomized guessing or something. Then it no longer becomes a pattern classification problem. Fine. But now most of the time we will not be interested in getting the prior information. I mean, we will not only have the prior information, but we will also have some additional measurements which we are doing. So that is, so in this case, it is my feature vector, which is my pitch value. So I'm calling that pitch value as X. So now the modified question I'm trying to answer is, what is the probability of the gender given X? Given the pitch value, what is the gender which is going to be, which I want to predict. So in essence, I will expand it as P of G is equal to F given X. So this is the probability that it is a female voice given the pitch value, and this is the probability that it is a male voice given the pitch value. And if this probability evaluates to, let's say, a higher value, let's say 0.7, and this evaluates to, let's say, 0.3, these two will add up to 1 because we are assuming that there are only male and female. Okay, and if this is the case, then our classification rule should be that if this is greater, then we will classify it as girl, as female. Or if male probability is greater, then we will say it will be male. That will be how our prediction will be. So this is if we have this extra pitch information available to us. So now the prediction from P of G becomes P of G given X. Yes, okay, there are some messages. Let me read what you have said. Second voice in robotic. So maximum money, we need to always output F. Okay, yeah, that maybe if you are in a only girls college, maybe you can output F. So Jainan is saying, so basically we are deciding based on the distribution in the sample space, which is an indirect way of saying that we know the probability of each class. Yeah, basically we are deciding, yeah, if no, see, this is nothing but common sense. Whatever I have said now is common sense. Okay, whatever I have said now is common sense. Now, suppose you are in Chandigarh, okay, or some okay, suppose you are here. I mean, yeah, you guys are not in IIT Mandi, but suppose you are in IIT Mandi. In Mandi there is a shop which sells flowers. So I want to know the probability of getting jasmine flower from that shop. Okay, jasmine flower. So I can sit at home and I can predict and tell that, okay, the probability of getting jasmine flower in Mandi is like 0.00001. Okay, it is non-zero because by some freak of some transport or somebody might have come and dropped some jasmine flowers to sell, but that the chances of that is very, very less. Okay, so that I can sit at home before going to the shop. I can sit at home and decide because I know Mandi, I know about Mandi, I know what type of stuff is there. So my prior knowledge there helps me. Or I can go to Mandi, go to the market, and go to this sports flower shop and ask him, okay, do you have jasmine flower? And most likely that guy will say no. Okay, so there now they have some extra information here. So now there I'm saying what is the probability of jasmine given X, where X is the event that I've gone to the shop and I've asked that guy. Okay, so before I go to the shop itself, I know from my prior experience that this fellow is not going to have jasmine. But if suppose I were in Chennai, then sitting at home itself, I can, if I think of any flower shop, the probability of getting jasmine flower is like 95%. Because I know in Chennai, jasmine flowers are popular. So that is my prior information. I will not be 100% sure because jasmine flowers are popular. It might run out. I have to go to the shop in Chennai and ask that guy. He might have it. He may not have it. If I go early morning, I might get it. If I go sometime in the evening, I may not get it. Okay, so that is my P of flower given X. X is the probability. I mean, X is the event where I've gone to the shop and asked. So that is the difference between the prior probability and the conditional probability. So it is actually a conditional probability. P of G given X here is essentially a conditional probability.
Hello, sir. Sir, I had a question about the earlier scenario.
Okay, wait 1 sec. How are we on time? We are 148. Okay, I'll just take one question because I want to wind up because I have another class. So I will, and I'll meet you guys again tomorrow. I mean, in the next week. I mean, next lecture I'm planning on Wednesday. Okay, Wednesday E slot. So I may not be able to send the email, but do attend the Wednesday E slot.
So tomorrow morning lecture.
No, tomorrow there is no class. Tomorrow there is no lecture. Wednesday E slot.
Okay.
Wednesday.
Sir, what you were essentially saying was that if there are
No,
100
somebody else
people,
had a question. Wait, Komal, did you have a question?
Yeah. If probability equal to gender equal
I'm not
to
able to hear.
female and
I'm not able to hear you. I'm not able to hear you. You have to. Can you type? Can you type?
Sir, am I audible?
Yes, Arjun. Arjun is the B19. No, this
Yes,
I
sir.
don't know the Arjun. Yeah, please go ahead.
Sir, what you were saying essentially about the previous scenario was that if 100 people spoke in succession and we couldn't hear their voices, then we should say female 90 times and male 10 times according to the distribution of male and female, right? That's what you were saying.
In sequence. Why do you say in sequence?
No, but yeah, my point is that we won't know which 10 out of those 100 will be male. So maybe
Yeah,
we are
that you have
better off
to
saying
come
F
up.
all the time.
You have to come up with some mechanism. I mean, like to decide. I'm not talking about anything sequential here. I'm just saying randomly at some time, if you, I mean, like at any point of time, the device has to tell you whether it is M or F.
Yeah,
So it
but
is
if
not
those
that
if
it
those
is listening to the past 5 minutes and then telling me nothing like that. It is at any point of time, it should tell you whether it is M or F.
so if those 10 males are distributed randomly across the whole set, then maybe we should just say F all the time. Because we don't know
No,
which 10 out
I
of
didn't
those.
understand what you're saying. I didn't understand what you're saying.
No, we don't know which 10 out of those 100 people will be male. Like we don't know if the second person will be male. Maybe the
Yeah, we
10th
don't
or
know. We don't
99.
know. Yeah, we
So
don't know.
if we don't know that, then maybe we should just say female all the time.
All the time.
Yeah, because we don't know which 10 out of those 100, like.
No, but if it is known that the college has 10 male faculty members, and those male faculty, there is equal chance of those male faculty members being around the machine as there are females. It doesn't make completely correct to always say female, because at some point some male will also be there.
But we don't know at what point a male will be
I
there.
wanted to add
That we don't know.
something to this. That
That we don't know. I'm just saying, if nothing else is given to you, if no other information is given to you, you only know approximately that there are more. I mean, like you only know that there are more women than men. Then it makes sense to say F most of the time. It makes sense to say F more times than it makes sense to say M. That's. I'm not making any strong statement here. I'm just saying this, that if you know beforehand that there are more women, you should say F more times.
Sir, I'm saying that we should say F all the time then. If we don't have any other.
No, because there is a chance that you will. So if you do this experiment, like if you keep the recorder there for 100 days or something, and each time every day you make some 15, 16 predictions, and somebody is there to say whether those predictions are right or wrong. If you say F all the time, suppose you say F all the time, and there is somebody else who says 90% of the time F and 10% of the time M, then that second fellow will get more money than you. There is guaranteed. There is theory. That is theoretically proven. Yes, Pratishta.
I was actually just adding to what Arjun was saying, that I get what he's thinking, that that is going to maximize the reward. In case one day only itself I'm listening to 100 people and giving. But if I am taking saying female all the time, I'm going to stuck in a suboptimal area, like a local optimal area, which is going to give me a reward of 90. But if I keep the distribution, I'm likely to get a reward higher than 90, which will not happen in case I'm just saying female all the time. So just saying female all the time is not going to be a good strategy that way.
you are also saying that saying female all the time is better.
No, I'm saying the opposite of that.
Okay, that's what even I said. Yeah.
Yeah.
Yeah, so I am explaining this to give you an idea of what is prior information. Okay, so you know what is prior information. Okay. Okay, somebody has said that. Okay. P. Any other question? If P. Komal has said PG equal to F given X, nothing is given. No. PG equal to F given X means X is given to you. So you already know the pitch value. Okay. So I will stop here. We can meet on Wednesday. I don't remember the time, but we'll meet on Wednesday. E slot. Okay. E for echo. E for echo. Okay.
Excuse me,
See you
sir.
guys.
Excuse me, sir.
Yes.
So if we calculate the probability by, I mean, when we are saying 90% of the time female and 10% of the time male, so then there are 90 females, and then we are saying 90% of the time female. So then the probability of getting female right is 90 into 90 by 100. Like 81 times we'll get female correct. And when we'll calculate for the male, it will be 10 into 10 by 100. That will be only one. So it will make a total of 82 out of 100 guesses on an average that we'll get correct.
I don't understand what you're saying, but here, okay, there is an assumption here that we are assuming that our predictions are all based on IID, that is independent. What is IID?
Independent and identical distribution.
Independent, identical. So we are assuming that the observations we are making are independent and identical. Okay, so that is a strong assumption. So so whatever I said is with respect to that assumption. So in practice, if the device is kept in a location, let's say where girls tend to cluster more, then it no longer is IID. Here we are assuming it is IID because we are assuming that the device is in such a location where the chance of meeting a girl is 90% and the chance of meeting a boy is 10%. That assumption is also there. Okay, so let's stop here. We will meet on Wednesday. Okay. Fine. Thank you. Bye. I'm stopping the recording and I'm ending the call.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.